Namaste. I welcome all teachers and participants for the course on sampling. First things first, there is no mathematical background is required for the participants. I will assume that you wish to use quantitative, qualitative or mixed methods research design in your research. Basics are dealt with required rigor, and you have self-learning material given according to the norms in the second quadrant of 4-quadrant learning, which we follow. Activities by you. We encourage you to use open source software such as R, which will be highly helpful to you. Before using those software, please do understand the theory. There will be discussion on common mistakes in statistics. Please use discussion forum for posting your questions. All your questions will either be answered or find a reference or a person will answer these questions. This is the first module followed by other lectures. Let me give an overview of the entire sampling which you are going to learn during the course of time. First thing is, you make observations about organizations. Since this is under human resources course, what I expect you is, you will be going to any organization which is a very mature organization, something like Bajaj, or a new startup, or some organization like Infosys, which had enough experience in IT industry. Therefore, we will be studying seminal studies on what kind of research design will be most suitable by way of a methodological fit. You will see that as we go on, there will be a separate lecture on methodological fit. Now, once you make the observation, you will be having a set of research questions. These research questions are obtained from the first initial observations you made about the entire your space. And based on this, you will generate theory. And this generate theory based on published papers. For example, if on motivation, you found that the motivation is low despite paying employees very high salaries, you should find what are all the kinds of other variables which are likely to impact the performance of employees other than just high salaries. Therefore, based on these theoretical aspects, you generate premise and hypothesis. These hypotheses are basically going to be your prediction how the various variables that you have identified are likely to impact the outcomes. Generate premises and hypotheses. Now, these hypotheses have to be definitely based on variables, and you will be seeing the different variables that you have to identify in the given observation, and based on these hypotheses, you collect the data. And while collecting the data, you will be measuring these variables and collect these data and test them for your finding whether these hypotheses can be rejected or accepted. And based on these tests, you will analyze the data and create a model. Overall, this is the basic introduction for your entire course. You will be finding the sample size determination, sampling theory, and effect sizes, power test, and all these areas are intermixed in this paradigm, what I am showing you now, and we will be taking each one of those aspects and discussing for our study on sampling. Introduction of topics and broad questions answered in the lecture. In the first part, we will describe methods that are used for selecting the samples. There is a practice session on selecting samples using Randomizer software. Introduction of topics and broad questions answered in the lecture are as follows. In the second part, we will discuss how information gained from sample is likely to vary from corresponding information for the population and what is the relationship between the population parameter and sample statistic. This will form the foundation for statistical inference, which we will discuss in the next lecture. Definitions. If you are planning to study television viewers of New Delhi, whose number may be in millions, and you wish to pick up 1,000 users to make a decision about all the viewers in New Delhi, you are using two concepts. One is population and other sample. The basic unit of population is called an element of the population. Each television viewer is an element of viewer population. A population is a theoretically specified aggregation of elements. This is the definition of population. You have defined them as a set. Collecting information about all the elements is known as census or making complete enumeration. However, doing census or enumeration is a very costly exercise. Therefore, we generally use samples in order to have information about population. A sample frame is a list, index or records from which the sample will be drawn, which might not be totally inclusive of the study population. We have to understand a very important point here. From the population, you will be taking a set which we will call it as sampling frame. In sampling frame, you will be taking those elements which are active among the population. For example, if you want to study all the students who are enrolled in MBA, what you have to do is, it is not the students who are just enrolled in MBA you should study. In fact, they should actually be studying. Therefore, there may be a large number of people who have enrolled, but a small percentage of them would have left the course in between. Therefore, you have to take only those people who are actively involved in the process of getting education of MBA. Therefore, sampling frame contains active elements of the population. Therefore, sampling is a process to select elements from a population. A sample is a subset of population elements that results from a sampling strategy. Therefore, what happens is, you have to use the sampling strategy in order to get the required sample. Therefore, what is the sampling strategy that you will be following? You will be following probability as well as non-probability strategies to get the required samples. Now, the first thing is random samples. Let us understand the meaning of random samples, very important. Statistical sampling theory provides methods used for solving applied problems, and the theory is based on random samples. Random samples or a probability sample is a sample selected in a way such that every element of the population has a known chance, that is non-zero and need not be equal in all cases, of being included in the sample. Random sampling is not haphazardous or absence of procedure. It is a selection procedure that guarantees a known non-zero chance of selection for each and every element of population. Why random sample is so important? Most of the publishers require us to have random samples, but not in all cases, but definitely in majority of the cases there is a requirement for random sampling. Random sampling eliminates systematic biases by giving all elements in the population a given chance to be chosen. We will discuss about these biases in a next separate lecture. However, it is enough for us to understand now that random sample is a chosen sample. It is better to understand it as randomly chosen sample than as a random sample, as dictionary defines it as having no specific pattern or objective or haphazardous. Therefore, here I have given a link of the common mistakes made in statistics. You have to go to the link and just see what exactly, why random sampling is so important. If you want to study the attitude of Delhi University students on climate change, and you visit university on a random day and meet 100 students randomly, it is not a random sample. You have excluded many who may be absent or gone on vacation. The right way is to take the list of all students in different years and use it as a frame and number them and use random numbers to select the calculated sample size. This step is important as it will help us to quantify errors and minimize them. If it is not random sample, we may not be confident about our results. Simple random samples. A simple random sample is a sample selected in such a way that it satisfies two conditions. Every element in the population has the same chance of being selected, and every sample size of n has the same chance of being chosen. This is very important. There are two conditions for it. Let me illustrate with an example. Binod, Charan, Deepesh and Ekanta, 4 research scholars. All 4 want leave on a vacation and only 2 can be away. You may put B, C, D and E, the initials of these research scholars, in a paper and put it in a container and request another scholar to take 2 papers. Thus, each scholar has equal chance of being selected. The possible sample size of 2 that are selected will be BC, BD, BE, CD, CE, D. If you observe, B is chosen in 3 of the 6 samples. Thus, probability of B being selected is 3 by 6 half. Similarly, probability for C, D and E. Each of the 6 possible samples has same chance of 1 by 6 of being selected. Thus, both the conditions are satisfied. Therefore, each element and each sample size should have same chance of being selected. This is the process of simple random sampling. Let me give an example. In a medical study, you wanted to study population of all hospitals that are performing heart surgery. First, find all hospitals that are performing surgery and ensure that they have performed at least given number of heart surgeries for the past 2 months. Number them as 1 to k, and this list is known as the sample frame, as it includes active elements of population. Determine the sample size scientifically as discussed in the lectures, and you may use the randomizer software to obtain random samples. Now, let me give you an understanding of research randomizer software. You can always generate the samples which are random. Now, you may generate the needed random samples from the numbered frame you have created. You have to plug in the following required information, which is decided by you. How many sets of numbers do you want to generate? The first question it will ask. You may generate one set or you may generate two sets. It all depends upon you. For example, if you are doing an experimental research, you may need to have two sets. Or else, if you are going to give a questionnaire and then trying to find out information from them, you may require only one set. Now, number ranges from 1 to 50. For example, you can have numbers ranging. For example, if you go to an organization where you find 1,000 employees and you need to select from them, give as 1 to 1,000. Do you wish to sort the numbers that are generated? This is very simple. It sorts the number from smallest to largest. And how do you wish to view your random numbers? You can download the random numbers and then you can have the entire set available for you to view or to print. Now, this is what is the results I have got. Now, I have generated two sets of 30 unique numbers per set. I assume that you want to experiment with one set, another set is a control. The range is sorted from least to the greatest. You can try different values, which we will be trying it while working with the randomizer software, so that it is easy for you to get the required random samples from the sample frame you have generated. Now we will go to the website Research Randomizer. We have also gone through the process of random number generation. Anyhow, for the sake of repetition, I will just explain to you how to generate numbers. Let us imagine that you have gone to an organization and where there are 2,000 employees with similar characteristics. Most of them are working in the organization, and you wanted to do an experimental study among them, and you have identified the sample size as 400. And out of 2,000 employees, you want to choose 400 employees, and these 400 employees are all serialized. That means you have numbered them 1 to 2,000. And you wanted to do, let us go for correlational analysis or cross-sectional research, in which you would like to give a questionnaire in order to find out their job satisfaction. You have gone through various instruments and you found one such instrument is most suitable for your research, and you would like to give that instrument to these 400 employees who are randomly selected from 2,000. Now, the number of sets that you can generate, you can say that you want to generate one set, and numbers per set is 400. You have told that your sample size is 400, therefore you would like to select 400 people, and the number ranges from 1 to 2,000. Now, do you wish each number in the set to remain unique? That means you don't want a number to be repeated if you have different sets, but here in this, you want them to be unique. Sometimes you may get multiple numbers who are equal, but you don't want that because you want 400 out of 2000 who are unique. Therefore, yes. Do you wish to sort those numbers? For example, you can sort them to least to greatest or greatest to least, depends on your requirement. And the next area is, how do you wish to view your random numbers? Place markers off, not much value addition, but let us see what is the randomizer now. It gives you one set of 400 unique numbers and they range from 1 to 2000, start sorted from least to greatest. The first test is 6, 10, 11, 14. You can see all of them are unique and they are random samples. Therefore, if you can choose these numbers, you will be able to get a random set of numbers on which you can use your research document. You can download the entire results and attach it with your thesis, or you can print it. Both these options are available. For example, if it is in a print version, you can see the print version given over here. You can see the complete results being printed, which you can use it for attaching with your thesis work. Please do get in touch with us if you have any questions. Now you can see these numbers range from 6 to 1993. That means it has selected various numbers in between from 1 to 2000 which are random. Thank you very much. Now let me go to systematic random samples. A systematic random sample is a sample which contains every ith element of a population. Let us consider 20 elements of population as given here. A, B, C, D, E, F, G, H. Up to T, there are 20 elements. And every fifth element is to be in the sample. We need to start with one of the 5 elements, A, B, C, D, E. Therefore, we will number them as 1, 2, 3, 4, 5 respectively. We try to obtain a random starting point from a table of random digits. Here is the random table that I have got it from the internet, which you can use it. I took a snapshot of random number table available in the internet. We need to decide beforehand that we will choose first digit that may be usable for us from 1 to 5. From the numbers starting in the 4th row and the 8th column. Therefore, randomly we will think that we will take a number starting in the 4th row and in the 8th column without looking at the table. Then we look at it and we get the number as 47200. Out of the digits 47200, the first digit is useful. For example, if the first digit happens to be 0, I think we may have to use the next digit. This is within 1, 2, 3, 4, 5. Thus, every 4th element will be a sample. In this case, it is D, H, and so on. In the discussion, we have seen that every element has a known non-zero chance of being selected as the starting point of the selection is random. Therefore, we have a random sample. However, remember one important thing. The samples we get from simple random sampling are not the same as systematic random sampling. They are different methods. Therefore, both are different methods for you to be followed. It depends on you what kind of a method you will follow in order to get your appropriate results. Now we will practice the randomizer by actually using the software. Now, stratified random samples. The next method is stratified random samples. In this method, we divide the population into non-overlapping groups, and it is called stratification. If the population is stratified and random sample is selected from each of the stratum, and this process is called stratified random sampling. If there is a large amount of homogeneity where most of the samples have similar characteristics, probably we may be using simple random sampling. On the other hand, if the entire population has different kind of stratas having characteristics within the strata are very similar, but between the stratas are dissimilar, stratified random samples is the right process for you to use. This process is to ensure that samples of adequate size are obtained from each stratum. Let us assume that we want to study education levels of persons between 18 to 28 in our country. If you take India's total population, some of the smaller states may be missing from being represented. Therefore, it is better to create a strata such as states of India and then use random samples to generate the given sample. Stratified random sample in practice. If you find the difference between the stratas is high and within the strata are low, it is better to use stratified random sampling. Let us assume the following data, which is extreme, with small numbers and large values. The population total sum is 530. We will plan to estimate the population sum by random samples of 2 samples we pick up and multiplied by 5. This is just a thought. Now, a simple random sample may yield poor results. For example, we select 2 samples and they happen to be 2 and 4, and I add 2 and 4 and multiply with 5 will yield only 30. Then we stratify into 2 groups. The 2 groups are now in the form given here, and now a single random sample from each strata may give one pair 2. For example, I may get 2 from the first set and 100 from the other set. Now 2 plus 100 is 102, multiplied by 5 will give 510, which is a better estimate. I have given a very simple example for you in order to understand the usefulness of stratified random sampling in practice. Now, we have seen 3 very important random sampling methods we use based on the population characteristics. Now, there are non-random sampling techniques available for us. Non-random samples are judgmental samples. All non-random samples are judgmental. The term judgment implies that instead of chance, judgment of the researcher plays a role and elements of the sample has unknown probability of being chosen. Now, many a times we may consider that non-random sampling methods are not amenable to analysis and you may not depend on those results. To an extent, it is true, but you may be having only this possibility and you may require to get entire research in a shorter period of time. Therefore, you have to be careful in using which method you have to use. The first thing is convenient samples are selected just because it is convenient for the researcher. It is the lowest level in the non-random samples. For example, the frequently used sampling technique in market research is the quota controlled judgment sampling, and the sampling is done based on the population percentages. For example, the total population has 20% high income, 30% middle income, and 50% low income. Then by using judgment, as an organization may choose sample units. This is a convenient sampling. Next is availability sampling. Availability sampling is a technique in which elements are selected because the samples are accessible to the researcher. This may introduce bias in the sample. Volunteers are used for research and they may not be representative of the population. But in many cases, you may get only the volunteers. Therefore, availability sampling is also being extensively used in many of the researchers. We may get the volunteers, but may use randomization in order to make the biases less pronounced. The next one is purposive sampling. It is based on researchers' knowledge of population elements in terms of research goals. It is used when there is good knowledge about who will be able to provide information on the domain. For example, in the case of medicine, you have a medicine which is being used for arthritis. I think the best way to go and get samples is from orthopedicians, maximum, and then from others. Therefore, here the researcher's knowledge of the population elements, who is likely to give a better information, is a very important input we will be using while sampling. The third one is snowball sampling. It is used to identify participants when population units are difficult to locate. To study drug addicts, it may be difficult to locate the population. In such cases, the researcher may choose snowball sampling to locate one or two addicts and get their confidence, and in turn may increase the respondents' number. Now, concepts in sampling. I will discuss here some of the key concepts you should understand while performing your research. The first concept is the estimation of population parameter by random sampling. This concept we will understand by using small population and get random samples from it and try to understand intuitively the sampling. In fact, better word is the power of sampling. Parameters and statistics, a relation between population mean and sample mean. Now, let us discuss. The population of students of Delhi University in a given year for commerce course may be 20,000 students, let us assume. We wish to estimate their marks in financial accounting. We will choose a random sample of 150 and found their average marks are 65. If you reflect on the results, you may say how it is possible to get data from 150 and estimate for 20,000. I think it looks little odd, but if you do some problems and definitions, you will find totally different results. A layperson may suspect these results, but not you, because you have understood sampling. Now, a parameter is a characteristic of population. Parameters and statistics, relation between population mean and sample mean. Now, most important thing is, let us understand what is the relationship between population mean and sample mean. We have seen 20,000 students are there in the commerce course and they have taken financial accounting, and based on 150 samples scientifically determined to estimate the population marks. Therefore, here let us come here. A statistic is a characteristic of sample. The mean of the population is a population parameter. Therefore, the mean of all the entire population of students is the population parameter. If a sample is drawn from the population, the mean of the sample is statistic. Therefore, we have two words. One is the mean of the population is called parameter. The mean of the sample is called statistic. The mean of sample is denoted by x bar and mu is used to denote the population mean. Let us have an example. Let me assume that there are 5 numbers in the population. There are only 5 numbers in the population, 0, 6, 12, 6, 36. The mean of the population, that is mu x, is given by add all the elements and divided by 5. It is given by 12. The population parameter is a single value 12. Now you know the population. Now you want to take a sample and try to find whether this sample will be able to give us information about the population parameter or not. Let us assume that we draw a sample of 3 units. Let us assume we have drawn 3 from the 5 samples randomly, 12, 6, 36, then their mean will be 12, 6 plus 36 divided by 3, which is equal to 18. Now, you can draw out of the 5 samples 10 different samples, and from the 5 population units of random samples. Our question is, what will be the means of all samples? That is, if you have 3 samples drawn, which are exhaustively 10 different samples you will be drawing, and the means of all these samples, therefore, you find mean of first one, second one, third one, fourth one, fifth one, and then find the means of all the samples. What will be that? Generating sample means from the population. Now, what we do is there are 10 samples that can be generated, and let us find all their means. Now, if you see the sample values 0, 6, 12, that is the first random sample you have drawn, and the sample mean is 6. Now, second sample, third sample, fourth sample, like that we have drawn different samples. And if you see the means of all these samples, it comes to 12, which is exactly the population parameter, that is a single value 12. That means the means of all means, the means of all sample means, that is 10 in this case, is 12. That is equal to mean of population. And I have given the probability frequency table of the sample means. You will see the sample means occur twice and the frequency is 2. We refer this as sampling distribution of the mean or probability distribution for the means of all samples of a given size that can be drawn from the population. As an exercise, you can take 4 samples and then see whether you will get the same results. Or as an example, you can take at a time 2 samples and find whether all means of all sample means will be equal to population mean. You will find the population mean will be equal to the means of all sample means. That is reason why the sample mean is a good estimator of the population mean. Now, relationship between the population and the sample distribution of the mean, we will use the following symbols: n for population size, mu x for population mean, sigma x for population standard deviation, n for sample size, mu x bar, mean of distribution of x bar, sigma x, standard deviation of the distribution of x bar. We'll be using these formulae, these symbols to represent the various connotations which we see in samples. Now, population and sampling distribution standard deviation. Now, we have to be very careful now. Population standard deviation and sample standard deviation. Now, it is not so very easy, because the standard deviation of the sample means is called the standard error of the mean, or by some others as standard error of S standard, or generally standard error. Now, what happens is, this is the sampling that you have. It has its own distribution, and its standard deviation is called standard error. However, the relationship is not very intuitive like the sample means and the population means. The formula for x bar to that of sigma x is as follows. Sigma x bar is equal to sigma x divided by root n. That means the sample standard deviation will be equal to population standard deviation divided by root n. Now, we can take the same sample population as in the example of 0, 6, 12, 6, 36 and compute x bar, and we use this formula. And the relation between the standard error of the mean and population standard deviation is given by the following formula. There is a small sample multiplier. If you are, in this case, I have taken only 5 samples. Therefore, you definitely need to multiply with this small sample multiplier, but it is not necessary if the n size is too big. If the n size is 100, it may not make much difference if you take a small sample of 10. Only when you take a small sample of 3 out of 5, you will get different results. Now, computation of sigma x bar, I have just given the figures, and I leave it for you to do this as a homework. Let us summarize. We started our entire discussion by initially finding out the you make an observation, you find what is the model fit, what kind of a research fit you should have. That is, we call it as seminal authors call it as the methodological fit. Therefore, when you make the observation, you have a methodological fit and try to study that and fit into a theory. Either if you are thinking that the present theory is able to explain that with little more constructs, then definitely you pick up you design a set of hypotheses, and these hypotheses you will try to find either can be rejected or accepted by way of statistical tools. And for all these, you have to reduce your biases and various other phenomena, and further, and then ultimately you create a statistical model where you can use it for prediction. So this, we thought, is the right paradigm for you to fit in wherever sample size comes into. Similarly, we have variables, and we will discuss different types of variables, which is very important for you to determine what kind of a sample numbers you should have. And once you have got the broader picture, the next step that we have done is to really understand what are all the different types of sampling. So we have random samples and non-random samples. And in the random samples, we have seen 3 methods. And in non-random samples, we have seen 3 methods, 3 to 4 methods. Now, once we completed discussion on those sampling methodology, we went to one of the most important aspects in sampling is what is the relationship between the population mean or the population parameter, that is the mean, and sample statistic or sample mean. you find that sample mean is a good estimator of population mean, because the means of all possible samples is equal to the mean of population. The next one is, we have also seen the relationship between population standard deviation and sample standard deviation. Now, with this discussion, we will go to the next lecture, where we will be discussing more on proportions and use of sampling for various other decision making purpose. Thank you very much. Please do join us in the discussion forum. Please post your ideas, thought process, and we will discuss more and make this course more useful for everyone. Thank you very much.